Hello. Yes, we welcome you back to PSSB, a Physical Sciences Silver Bullet, and this is me, Richard here. Yes, tonight we are looking at this question. It says that a 10 kg block is being pulled by a constant force F over a rough surface. The initial velocity of the block at the bottom of the ramp is 2.84 meters per second. The final velocity of the block at the top of the ramp is 8.46 meters per second. The height of the ramp is given, and then the question comes, what does it say? It says that draw free body diagram showing all forces acting on the block as it is being pulled up the ramp. Okay, this is the case we are having. And how do we go about this? Okay, first of all, let us start by showing our ramp, our incline. They said free body diagram. So suppose this is our body, which is our dot that side. And then we indicate there are some forces which are obvious. We have the applied force there. Okay, which other forces do we have? Okay, we have the gravitational force, which is acting vertically downwards. And our block is sitting on the ramp, and that creates the normal force. But they said that the surface was rough. What does that mean? That means that there is friction force on this surface, and friction force opposes motion. So if the body is going upwards, our friction force is parallel and opposite to displacement. So this is it. This is the free body diagram showing all forces which are acting on our block. And so comes this question. It says that calculate the total work done on the block by non-conservative forces when the block is moved from X to Y. Okay, here you have to remember that our block here is having conservative and non-conservative forces. Actually, there is only one conservative force which is acting on this block, and that is gravitational force. But there are other non-conservative, like the friction force, like the applied force, and they want us to calculate the total work done by non-conservative forces. Okay, to do this, the best approach is to have this equation. It says that work done by non-conservative force is equal to change in potential energy plus change in kinetic energy. So that is the easiest approach we can use here. So from here, what do? We can find each of these. Let's start with change in kinetic energy. Okay, what does that mean? It means that it's a half mv f squared which is the final kinetic energy, minus a half mvi squared. Okay, when you come to substitute, what do we have? You have the mass. The mass is 10 kilograms. You have the final velocity, which is 8.46, but you have to square it, minus half times 10 times initial velocity, which is 2.84 squared. What you get out of that is going to be our change in kinetic energy. So that is what we get. Then after finding this, then we go for this. What do we have here? Change in potential energy. And this one is supposed to be mg h final minus mg h initial. Okay, we know m. What's the mass of the block? It is 10 kilograms. Times g, which is 9.8, times the final height, which is 6.5. Then minus 10, that's the mass, 9.8 times initial height. X is our reference, so it is 0. And what you get out of this one, it is going to be our change in potential energy. So that is what we get. But we have to remember that we have this and we have this, and they are substitutable here. So what are you going to say here? We are going to say that work done by non-conservative force is equal to change in EP, which is 637, plus change in EK, which is 317.53. So what you get out of that is going to be our work done by non-conservative forces. So that is it. It is 954.53 joules. And with that, would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. Yeah, don't forget to subscribe, to like, to comment, to share. We are simply the best. See you then. Bye-bye.